In section 7.8, we're looking at translating English phrases and algebraic expressions. Here is a graph, a chart that shows many common words and what they mean in math. So you can see the different words that mean to add, subtract, multiply, divide, exponents, parentheses, and then the equal sign. We're skipping question 1 because we didn't do chapter 1 in this class, but keywords for operations are very useful when talking about math in the classroom for homework, giving directions, etc. If you don't know how to properly translate English phrases into mathematical notation or the other way around, you don't have a full understanding of math. When describing math expressions, it's important to use words that are not ambiguous. Their meaning must be clear so that the correct expression is written in math symbols. So just like with our PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, the need for having a set order to solve a problem so people would not get different answers for the same problem, we need to make sure that we understand exactly what's going on and being able to describe it to somebody else in words if we're reading a problem. And so for the next questions, notice it says for each algebraic expression, an incorrect English phrase is given to describe it. And so we need to rewrite the phrase so that it's not ambiguous. And there can be more than one way to write that. So first what we're going to do is actually write what it says and then fix it to what it's supposed to say according to the equation that is given, the expression. And so when we look at 5 times a number plus 1, 5 times a number, and are using n to represent the number, would be just 5 times n, and we know we don't put the multiplication symbol in between them, we just put them together. And then it says plus, which means add 1. So 5n plus 1. Notice it's similar to what we have except for the parentheses. And again, if we were looking at our orders of operation and we were going to substitute a number in for the letter n, we would not get the same answer as we solved it using the parentheses without using the parentheses. So we would need to fix the wording so that it is understood that addition comes first and then the multiplication to 5 comes second or last. And so there's one way we could write it that says possibly 1 more than a number is multiplied by 5. So that clearly states that we're adding first and then multiplying by 5. Or we could say 5 times the sum. So it's specifically stating we're multiplying the sum, which is the answer to an addition problem. So we have to add first in order to get that sum. So 5 times the sum of a number and 1 would be another way that you could say that. So again, both of those are clearer than just the 5 times a number plus 1. For our second one, we have in words 3 less than the quotient of a number and 2. Well, less than, if you have the word then, it's really important to understand that you have to have something to start with in order to take away from it or add to it. In this case, less would be take away from. And so the order that they have it puts the subtract 3 seconds. So 3 less than, and what are we subtracting from? The quotient. In math, it's easiest to write the quotient as a fraction. We know that the fraction bar means to divide. So the quotient of a number, so n would be our numerator because it's listed first. The word and means we're switching to underneath that fraction bar, and 2. So the way that it's written is that the fraction comes first and then we're subtracting 3. So that word than is key here of having the order being different. And so we could change it by simply taking out that word. So we can just write 3 less the quotient of a number and 2. So just deleting that word than makes a big difference. Or we can say the difference of 3 and the quotient of a number and 2. So again, there's 2 different ways that would let somebody hearing this know that the 3 comes first, and then the quotient, again, think of it as fraction, comes second. Here we have 5 times 3 times a number minus 4 is the words. So let's put that down. So 5 times 3 times a number minus 4. So again, just like one of the other examples, it doesn't tell us that we have to do some subtraction before we do multiplication. So we need to make sure that that's clear. So one way we can write that is 5 times the difference. So again, 5 multiplied by the answer of a subtraction problem of 3 times a number, and the word and there refers to the difference, so that's where your subtraction sign will go, 4, or we could say the difference of 3 times a number and 4 is multiplied by 5. So there's 2 ways that you can write the words again to make sure that it's clear what operation gets done when. And again, there could be more ways than writing that. I'm just giving you 2 examples. And the last one we have as an example is 4 multiplied by a number squared. And so that one I would show 4 multiplied by a number. So again, I'm not putting a times sign in there since it's a number and a letter next to each other. And then the number squared. So as you can see, the example, I guess I'm using n instead of x where they changed up the variable. It doesn't matter. I can just fix that real quick and say that these are supposed to be x's. But it doesn't matter what letter you use unless it specifically tells you what to do. But anyway, back to this one. The statement that they gave us, the expression, shows that the 4x gets multiplied together and then squared. So it's saying 4x times 4x. Where we have 4x squared, it's only the x that's being squared without the parentheses. So we can say the square of the product of 4 and a number, or we can say, just reversing the language, the product of 4 times a number is squared. So the product is squared. The answer of the multiplication is squared, not just the number itself and nor x. So then you have to be careful how you're wording these. But for most things, you're going to be taking the words and translating it into the expression with the variables. And so you'll get practice doing that next. Here you have some problems to try. For number 7, the answer key is wrong. even though we know order doesn't matter in addition. So for example, 2 plus 3 is 5 and 3 plus 2 is 5. But since we're translating, we need to make sure we're following what the words say. And as I mentioned before with the less than, more than means we have to add 5 to something that we're starting with. And so the plus 5 would go second, and what we're adding it to follows with the 3 times a number. And so if you want to use X and P, it doesn't matter what letter you're using. But the answer key has the 5 coming first, which according to the wording of this problem is wrong. So make sure you pay attention to the wording for these. And then when you get to numbers 10 and 11, notice that again they're trying to show you that difference. We have basically the same thing but worded slightly different. And so again, that word than is playing a part with the order. So try these questions, and then when you're ready, move forward and we can look at some of the story problems together. A group of 7 friends are planning a party. They want to buy 8 sandwich party trays, which cost X dollars each, and evenly split the cost. Write an algebraic expression to describe how much each friend will contribute. So we know if we're splitting the bill, we add it up and then divide by how many people are splitting the bill. So the total amount of money we are spending is 8 trays times the dollar amount, which we don't know. They tell us to use the variable X. And so we're dividing that by, it tells us there's a group of 7 friends. So we have division, again showing as a fraction bar, the quotient of 8 times the number and 7. Due to a miscommunication, 2 of the friends bought cups. One friend bought 3 packs of cups and the other friend bought 5 packs of cups. Each pack contains C cups. Write an algebraic expression to describe how many cups the 2 friends bought. So one of the friends bought 3 packs. Each pack holds the amount C, so 3 times C would give us the total cups there. And our second friend bought 5 packs, expecting a large crowd. And again, we have C amounts. So we could simplify this if we wanted to. It doesn't ask us to, but we could simplify that and say that we have 8 total packs of cups being bought, and each package holds C amount of cups. Alicia runs her own computer repair business. She charges $75 per house call and $45 per hour to repair the computer. Write an algebraic expression to determine how much she will charge if it takes her H hours to repair the computer on the house call. And so $75 per house call is just a flat fee. It doesn't matter if she does anything or not. When she shows up, it's 75 bucks. And we're adding to that $45 per hour. Per means multiply, and it tells us it's H for the hours. So the way it's written here would be we're taking $75 and we're adding to it $45 times the number of hours H. And if you write it in reverse, it's still acceptable because it's not telling us that we have to translate word for word. And so again, it wouldn't matter the order. And most times when you see algebraic expressions, they have the part that has the unknown, the variable, first, and then the constant being added last. So either way is acceptable, 75 plus 45H or 45H plus 75. But then we're going to use that now to solve a problem. Use the expression from part A to determine how much she would charge a client if it took her 4 hours. So now it's telling us H is 4. So we're going to plug in 4 as our H. So $45 per hour times 4 hours plus the $75 house call. Well, 45 times 4 is 180. So we have $180 plus the $75 house call fee. So that gives us a total of $255 to repair the computer. I don't think I would spend that much on my computer. I would just use that towards a new one. But if it's a really nice, big, expensive computer, then it would definitely be worth paying the repair charge. Okay. Andy orders pizzas for himself and his friends. The cost for a large cheese pizza is $9.99 plus $10 for each topping on the pizza. He orders 4 large pizzas, 2 with 3 toppings, 1 with 1 topping, and 1 with 5 toppings. Write an unsimplified expression for the total cost. So let's go for what they're saying. We have 2 pizzas with 3 toppings each. So 2 pizzas with the cost without any toppings is $9.99. And then it is $10 per topping, and then those 2 pizzas had 3 toppings each. And we're adding to it 1 pizza. Let's make this pizza red that has 2 toppings. So again, we have $9.99 plus the cost of the toppings. So 2 toppings times T toppings each. And then our final pizza, it says this one has 5 toppings. So we have $9.99 plus 5 toppings. So we need to simplify the expression. So let's look at the whole picture here. We have 4 pizzas. Each pizza costs $9.99. And then we're adding to it all the toppings. We have 2 pizzas with 3 toppings each. So that's 6 total toppings, then 7, 8, and then 5 more is 13. So we're having 13 total toppings to our pizza. And so if we want to simplify that a little bit more, we can multiply our $4 times our $9.99 to get $39.96 plus whatever the charge is per topping times 13 toppings, so plus 13T. So that's as simplified as we can get it, knowing the information that we know. So part C tells us that the toppings cost 75 cents each. So we can plug that in and get our total cost. So we have $39.96 for just the 4 cheese pizzas. We're adding $13 or 13 toppings, which cost 75 cents each. And so if we solve that, we get $39.96 plus 13 times 75 cents would be $9.75. And so we get a total of $49.71 for the pizzas. Gus is a pharmaceutical sales rep, and he makes a salary of $500 a week plus a 5% commission on his sales. So it's telling us that Gus is selling M dollars, so we don't know the total amount he sells first. Write an expression to show this. So in general, the rule to figure out how much he gets in his gross earnings, it's 5%, which as a decimal is 0.05, times the amount of money that he sells in supplies, so 0.05M. But then we're adding on to that $500 a week. So even if he doesn't sell anything, he still gets that $500. So for Part B, they're going to tell us that the M value, how much he sold, was $15,000. So let's see how much extra he gets in his paycheck. So we'll have to do 0.05 for 5%. Now times that $15,000. Did I say 1,500 last time? I did. I'm sorry. 15,000 plus the 500. So when we take 5% of 15,000, we get $750 extra just for his sales. So we add that to the $500 base pay. We see that his take home for the 1 week is $1,250. Okay. So again, if you have any examples that you're working on for your homework that you're not understanding, you need help setting up or explaining how to get the right answer, don't hesitate to send me an email. Make sure you screenshot it or type out the question, and I'd be happy to help. Otherwise, good luck with this, and I'll see you next time.